A 23.9 gram sample of iridium is heated to 89.7 degrees Celsius and then dropped into 20 grams of water in a calorimeter. The temperature of the water rises from 20.1 degrees Celsius to 22.6 degrees Celsius. Calculate the specific heat of iridium. So what we're going to use is this equation that gives the amount of heat in joules as the product of the mass of a substance times its specific heat times the temperature change of the substance. And the temperature change is measured by taking the final temperature and subtracting the initial temperature from it, from the final. So notice that we need to calculate the specific heat of iridium. So we would have to solve for this guy here, and we would need to find the temperature change, and this one we will easily find. But we don't know how much heat was lost from iridium, right? We know there's a certain heat associated with its initial temperature of 89.7, right? So a certain amount of heat is lost from iridium and gained by water, right? Because this heated iridium is dropped into a 20-gram sample of water, right? So water gains heat. So however much heat the water gains is going to be the same amount of heat that is lost by iridium, all right? And that will be the Q value that we're going to use to solve for specific heat. So naturally, we must first find the Q value of water, right? The amount of heat gained by water, right? So let's do that. So what's the, how do you do that? So amount, so we're going to denote it as Q of H2O. All right, so we're going to take the mass, and it says 20 grams of water, right? So 20 grams H2O. Now, what is going to be the specific heat of water? That you should that you should actually memorize is going to be 4.184 joules per gram. Okay, and also per degree Celsius of water. So notice right away what cancels out are the grams, but we also need to cancel out the degrees, right? And the way to do that is to perform one more conversion factor. And of course, in this equation, you know that one more factor will be the temperature change. All right, so temperature final minus the temperature initial. What is the final temperature? The final temperature of water is going to be 22.6, right? So we're going to write 22.6 minus 20.1, the initial temperature, okay? Degrees Celsius. So now you can see that the degrees Celsius will cancel out as units, and all you have left is the joules, and that's exactly what the Q value should be, the amount of heat. In this case, the amount of heat gained by water, right? So what this should give you is 209, if you do this correctly in your calculator, this should give you 209.2 joules, okay? So this is the amount of heat gained by water, and that's why it's positive, right? Because it should be positive means that it's gained, right? Not lost, but gained. So now we know that the amount of heat lost by iridium is going to be the equivalent of that, but only negated, right? So we're going to say Q of iridium is going to be minus 209.2 joules, right? Because that's the same amount lost by iridium and also gained by water, okay? So now we're going to use this amount for the iridium. We know the mass of iridium is 23.9 grams, and we know the temperature change, all right, for iridium using the numbers. We know that the final temperature of iridium is going to be the same temperature as the final temperature of the water, which is 22.6, right? So this is the law of equilibrium. 22.6 has to be the same temperature, final temperature of iridium. Because at a certain point, iridium and water will have the same temperature, right? So that will be 22.6. All right, so that's the final. And the initial, of course, is 89.7. So we know all of these parts, and the only thing that we don't know, the only component, is the specific heat. So let's solve for that. So let's substitute in the numbers. We're going to have minus 209.2 joules, okay, is equal to the mass, 23.9 grams of iridium, times its specific heat. So I'm just going to denote it as it is, specific heat, times the temperature change. And the temperature change will be what? The final is 22.6 minus the initial 89.7 degrees Celsius. And of course, if you solve for specific heat, you should divide this side by both of these at the same time, right? So the specific heat of iridium is going to be taking this number, negative 209.2 joules, and divided by 23.9 grams of iridium times the temperature change, which is 22.6 minus 89.7 degrees Celsius. Okay? So as a result, this will be proper. The specific heat will be measured in joules per gram and per degree Celsius of a substance, in this case iridium. Notice it matches what we had here, the conversion factor of specific heat. Right? Joules per gram per degree Celsius of the substance. Same thing here. Joules per gram per degree Celsius of the substance. In this case, it's iridium. In the first case, it was water, H2O. All right, so if you do this correctly in your calculator, you should get this result, 49152, or joules per gram per degree Celsius. All right, and if you round it, of course, you should round it to 3 significant figures. Okay, so if you round it to 3 significant figures, you should get about this. Right, per degree Celsius. So I hope this was useful and fun. Thank you so much for watching, and I'll see you in the next video.